Okay, hello everyone. So welcome to ARFoundation Beyond the Basics. My name's John, and I'll just start off first with what ARFoundation is. ARFoundation's, I suppose, what you'd call a meta SDK. It's an SDK that covers AR Core and AR Kit, and in the future, as we get more AR SDKs and devices coming out, it's going to provide a unified API, so you can write your AR experiences once, and it will run on different AR providers. At the moment, it just provides the basics, plane detection, feature detection, light estimation, hit testing, and AR anchors. So next year, you'll expect to see a lot more as we start to get image recognition and cloud anchors and these sorts of new features as well. And we'll also be exposing the ability to use AR Core and AR Kit specific features as well. So if there's something in AR Kit like your light probes you'd like to use and you'd want to do something platform specific, we'll provide the ability to do that as well. So I've got a fair bit to talk about, and this is beyond the basics, so I'm not going to talk about necessarily how to set up a basic ARFoundation app. I'm going to talk more about the usage and workflows around it. Talk about AR Mock, how you can start to test within the editor, and scaling and moving things around within the world, lightweight render pipeline, how you can use that with ARFoundation. Then I'm going to get into some code. These next two ones have some code involved, how you can grab the camera background and start to do maybe some image processing with it, and also how to make some custom plane meshes, how to configure the look, how to add to the look and feel of your application as well. Some tips, and then also Mars preview as well. So let's jump in. So AR Mock, what problems does this solve? At the moment, it's a bit of a pain if you want to test your application. You have to go and build the application to your phone, go and find a nice pattern or a well-lit area, try it out, and it's a long iteration time. So we have a mock-in, and we also have a remoting solution as well, but I'm just going to talk about the mock-in solution today. What this does is it lets you set up an environment within the editor. So you can put a plane down, you can create a point cloud, reference points, all these sorts of things to test out setting. And this is more than just convenience. The thing with augmented reality is it's used in it's used in lots of different conditions. Sometimes you're somewhere where it's dark, or somewhere where there's lots of shiny surfaces. Sometimes the world changes. And I often see AR developers testing in their office, which is nicely lit. They've got their perfect condition. They've probably actually put a pattern down on their desk. And so they're testing the best case scenario. And it's like when you're making a game, you want to test on old hardware. On AR, you want to test in the worst case thing. So imagine now, if you'd like to test that, you need to physically create those situations where you lose tracking or there's a bad lighting condition. So with AR Mock, you can actually set up different test scenarios that are difficult or aren't what you expect. So things like your planes changing, losing tracking. There's a simulate session object as well, so you can turn tracking on and off and make sure you're providing the right error messages and feedback. So this one here, we can change the probability tracking will be lost, how it make things move around and spin. And then I'll show you why this is important. This is the game view. So this is within the editor, and this is what that setup looks like. And notice we've got these white planes. These axes, red, yellow, and blue axes, are a reference point. And a cube is just a plain cube being placed at a certain position. But notice how the cube disappears for a moment there as the plane changes. So as we're using augmented reality and we look around the world understanding changes. And so your planes might lift up or move or disappear. Often you'll see, especially in the sample, you'll see an AR sample where they say cast a ray, test a hit point, and just put something in that position. And so you place your cube there, and then what happens is the plane moves, or the conditions change, and your object's still stuck in that same position. So one thing that this video illustrated, is that when you're placing objects in the world, put them on a reference, on an anchor or on a plane, so that as the world understanding changes, those objects will move and update as well. So that's AR Mock. It's already in ARFoundation. If you get the latest ARFoundation, you'll have the code there to drive it. but it can be a bit tricky to know how to set it up because all you get is the code, these simulate session code. It's stuck away in a package somewhere. It's harder to access. So if you'd like to get that test scene I just showed you, go to the samples, the ARFoundation samples GitHub. You can have a look at, there's lots of samples there for setting up a scene and whatnot. But go to this branch, this mock branch, and then when you pull that down, you'll have a scene that has that set up for you, and you can either then copy that into your project or do what you like with it. But it's a great example for how to get started. So scale and make content appear at. This is a bit of an obscure title. What this is solving is, there's a couple of things here. So there's this, usually when we're dealing with augmented reality, I'm dealing with something that's on a table, right? Or on the floor, or something that's at a different scale to what I have in my game. When I grab something from the asset store, I might grab a building that is, meters tall, and I want to put it onto my table. So I shrink it down. Usually, a lot of the time that's not an issue, and that's fine, but sometimes it can be. In Unity, sometimes world units matter. When we're doing lighting calculations, for instance, or physics calculations, a unit in Unity means 1 meter. And so if you shrink your entire world down and put it on your table, you might start to get funny results with physics or lighting. And so if you find that you want to have a way you can scale everything down and still have those things behave. So I'm going to show you, one solution to this is, instead of scaling the content, maybe I could scale the session, right? Maybe we always have an AR session, so I could scale that down. And so you can see here, when I'm scaling, the plane scales down as well, and the content I have in the world remains the same. But the issue is, the AR content is scaling down, which is great, but the world content is not moving correctly relative to that AR world. So there's a bit of a mind-bendy trick here, what we do. So this is the view from the game view of what we had before. So you can see the AR world and the rest of our objects aren't syncing up correctly. So here we can see it's working correctly. So what's been done here, I'll show you, this is moving things around, but we were doing scaling. So we're still doing the same thing here of the camera. You can see the camera and everything is scaling correctly. I can scale this island up and down and things are working correctly. So what have we done? What we've done is we've put the AR session at the center of this island. This is a bit mind-bendy, all right? So we'll wrap our heads around this. We put the AR session at the center of the object rather than where the camera is. So that means when we scale, we're scaling around the AR session relative to the AR session. So we've kept the camera where it is, moved the AR session there. You don't have to worry about the details of how this is done because the AR session object has a scale option that you can use, and you can use this in practice. But what I really want to emphasize here is how your code should change. So right now, this is the usual sample you'll see for ARFoundation. When someone taps the screen, you're going to cast a ray, and wherever that ray hits, you're going to put something in that position. That is okay, but what we should do instead is AR session origin, make content appear at. And what this does is, instead of moving the object, we're moving the camera or the session so it's looking at the object. So it's a bit like if I was to walk over to you, I want to go close to you, I could walk to you, or you could walk to me, right? It's the same sort of thing. We're just flipping it around. And what that means is we can do this trick with keeping that session origin in the middle, and we can scale the thing nicely, and we can move it so we have the correct view of this object. There's some advantages and disadvantages to this. The advantages is this object now doesn't move. So I can mark it as static, which is going to give me some rendering efficiencies. It means I can mark it as navigation static and put navigation meshes on it, that sort of stuff. But the disadvantage is I can only have one of them, right? If I'm looking at this table here and I tap on the table and I place something here, the camera is moving around relative to it. So if I have another plane over here, it's not going to have the correct result. So if you've got one world, one plane with something looking at it, then this is something that you could consider. I know this is a bit of a mind-bending concept, so there is a blog post about this that has these sorts of images and a deeper explanation of what's going on here. So if this is something you're interested in, you can find that blog post. So lightweight rendering pipeline. This is going to, obviously our new rendering pipelines are a really big thing for Unity, and they're meant for mobile. They're meant for mobile and VR, so it's going to make sense eventually for people doing augmented reality to start to use a lightweight rendering pipeline. It's lightweight, it's more efficient, you're going to get really great performance out of it. But as we migrate things to the lightweight rendering pipeline, we need to change shaders, we need to make some changes to make it happen. So the team have provided have added AR function, have added the lightweight rendering pipeline to ARFoundation, so you can grab that and you can start doing lightweight render pipeline stuff inside ARFoundation. Really what they've done is updated the camera background so it renders correctly. So what I've grabbed here, if you've used a lightweight render pipeline or the shader graph, we have a bunch of examples for the shader graph. There's a GitHub repository you can find and download. It's got a whole bunch of these player objects which are using the shader graph to do things. This is just one of those examples. I just grabbed those examples, popped one of those in AR. So now you have a visual tool you can use for developing shaders, and you can use that in ARFoundation as well. And those examples are a really great place to start. So if you want to use this, then here's the links for you. There's a blog post here. The first link is a blog post, which tells you how to install and use the lightweight render pipeline. And the second one is the same thing again. You need to go to the samples. I'm in the way here. You need to go to the samples, and again, we've got a branch here for lightweight rendering support, and that's just to show you how to get started. You don't need this second bit. It's just if you want to have a scene that's there ready for you, you're all ready to go and set up, grab that one. If you've got an existing project, don't worry about, you don't necessarily need to worry about the samples. Just go to the blog post. It's going to tell you how to download and hook this up, and you can start using a lightweight render pipeline for your AR experiences. Camera API. So this is where we start to dive into some code. This is a really common request. People say, okay, I've got ARFoundation working, but now I want to have access to the camera. Mostly it's because they want to do some image processing. They want to use OpenCV or some other image processing SDK or, to find things within the scene and put a marker on it, for instance, detect a face and put some information around the face, that sort of stuff, right? So this has been a big request, and so we've just added this recently, the ability to do this. I'll move out of the way again. So what I've showed you here is the first thing where I'm enabling this object, enabling this component. I'm just hooking this camera frame received event. So every time a new camera frame is ready for us, this function will now get called. And it's up to us what we want to do. So the examples I've given here are for the GPU side of things. So when a camera frame is ready, there are some textures there you can have access to, those GPU textures you can have access to. So on the first line here where I've said camera subsystem get textures, that just gets you the texture handles back. So you can do what you'd like with them. Be careful with this because on ARKit, you're going to get two textures back, the Y and the UV textures. And on ARCore, you're going to get the RGB one back, so you need to kind of know what you're doing in that sense. But they're there for you if you want to use them. The second example here is I've just said, okay, I'm just going to copy the texture out. Because once this frame is ready, it's ready to be rendered. The materials for rendering this are set up. So I can just say graphic split with a null first parameter, and it'll blit correctly into a texture, taking care of the multiple textures and all that kind of stuff. So that's why if you want to just capture this to a texture, you can use a blit command. Well, the last idea here is you could always pass this through to a compute shader if you wanted to use these camera textures for some image processing on your GPU. So that's one way. That's kind of always been what's been available for a little while. The new way here is if you wanted to copy these pixels and get access to them. So if you wanted to use OpenCV, for instance, you need access to the pixels themselves on the CPU. So we've added this new try get latest image, which returns you this image object. And then you just say what sort of format you would like this to be in. So for instance, for OpenCV, it doesn't use RGB, it uses BGR for historical reasons. So you can say, please give me a BGR image. And then in this last line here, this is a new API for Unity generally, where you can say get raw texture data. And this will get you all the pixels. This is from 18.2 onwards, this particular call. It used to be, if you wanted to get pixels out of a texture before, you'd have to call get pixels, and it was very slow because they had to copy all the pixels back. This is a more efficient way to get texture data. So once you've got this, once you have all the pixels here, then you can do what you'd like with them, and that's going to be some sort of image processing or edge detection or something like that you'd like to do with it. Okay, so this is a bigger topic, and again, I'm going to show some code on this. So you've probably seen, if it was like me, you're using lots of AR applications, you'll start to see the default plane a lot and the default point cloud a lot. You open up an app and you can see the sample, you'll start to see sample point clouds, you'll start to see ARFoundation point clouds, and you're like, if I make my own application going to all this effort, I want it to look and feel in a way that, something that suits my application or specific to my application. So you can go and, we have plane prefabs and point cloud prefabs, you can go and change materials on those, and there's some customizability you can do to make them look different. But if you want to go to the next step and do something completely custom, then I'm going to show you how to go through and do that. So this is really just the next step. You can customize without doing this, just to make that clear. But if you really want to go further, then let's talk about how you can make your own plane in this particular instance. So the AR plane object is something that's created and managed by ARFoundation. And what it has is just the points of the vertices of the points around the edge of the plane. And then the last point is the center here. So when AR plane has this update event, it gives you just these points. It's up to you how to visualize those. You can visualize those in every way you want. But to make this easier for you, ARFoundation has an AR plane mesh visualizer. So what that does is it hooks this update event, and it gets these points in, and it makes its own mesh, and optionally puts a line render around it as well. So it does this meshing thing for you, and like I said, you can put your own material in this, and it'll be fine. But sometimes you want to make your own, do something special on top of this. So what you can do is, when the AR plane mesh visualizer, it has an event mesh updated, you can hook that. So I've got this custom plane visualizer that can do something with it. And I've got a couple of examples to show you a bit more concretely why you might want to do this and what you can do with it. But just to show you what this looks like from a component point of view, we have the AR plane object, which just contains the idea of the plane, just the points, and that's from ARFoundation. We have the mesh visualizer, which again is from ARFoundation, and this is the bit that creates the mesh for you. And then I have this AR feathered plane mesh visualizer. This is something I wrote. It's in the ARFoundation samples as well, so you can grab this and use that. But that's a custom mesh visualizer. So why did we make this? Well, this is what it looks like. So what we wanted to do was, instead of having a hard border for our plane, we wanted to have a soft feather. We wanted to have a feathered edge, just to kind of encourage people to go towards the middle of the plane a little bit and convey the sense that a plane in AR doesn't necessarily stop and start like that. It kind of fades out in terms of accuracy and usability. So how would we go about creating a feathered edge like this? Well, usually you'd use the UV channel to mark where the edge is, but I need the UV channel for this blue kind of hexagon texture. So what I'm going to do is I'm going to use the second UV channel, UV2 channel, to just mark where I should start fading things out. And I'll show you what the code looks like. So not for this specific example, but give you an idea about how you could write some code to really customize the look of your plane. I should mention the point clouds are the same as well. You can hook point cloud events and do custom things with them as well, just using the planes as an example. So code-wise, this is what it looks like. This is you can get the plane mesh visualizer, which I've described, and just hook the mesh updated events. So whenever a mesh is updated, you can be notified. And so once this function gets called, what can you do? Well, I get access to the mesh that's just been created. So the plane mesh visualizer just recreated this mesh because the plane's changed on the ground, it's got a new vertices or it's got bigger. I can grab that mesh. I can grab the vertices out of that mesh and I can iterate through them. So what I'm doing here is, I'm doing just that. I'm grabbing the mesh out, I'm iterating through that, and I'm calculating UVs for this fade-in effect. The math's not really important here. It's just what I'm doing is I'm going to say when I'm a certain unit in from the edge, a certain distance in from the edge, the UV is going to be 1, and then it's going to keep going from that. So I know at 1, a UV of 1, I need to start fading out. And at the end, what I can do here is I set the UVs back, and I use the second channel there, and then I update the mesh. So that lets me hook this process, this mesh updating process. And in the shader then, what I do is for, you can see in the third line there for the alpha channel, I go, okay, as soon as I'm past a UV of 1 for the second UV channel, I just start to fade out this alpha. I just smooth that out. So that's one example of updating what your mesh looks like. And again, it's again a more advanced one. You can slap a new texture on, use the materials, whatever you'd like, but I just wanted to show what else you could do. I've got one more example for this. So this is an AR app I wrote as a sample called Faces on Things. I just like the idea of putting silly faces on real-world objects and eyes on letterboxes and all this kind of stuff. And I wanted this to have a really custom look and feel. I wanted this to feel different to any other AR app. So I want to give a shout out to, there's an asset store package called Doodle Studio 95, ! And it brings Windows, Microsoft Paint style doodles into Unity. And so you can create these fun little 2 or 3 frame hand-drawn animations. So what I've got here is I've got a point cloud that animates, it's just stuff I've sketched. But the plane, you can see the plane here, it's very hand-drawn, has overlapping, the edges can overlap, and it's quite a custom look and feel. It doesn't really look like any other AR app. So how would I go about this? How do I go about creating a nice hand-drawn border for my AR planes? So the strategy I've used for this one here is to, when I get the plane, for each edge of the plane, what I want to do is I want to generate a quad that just sits along the edge, and that's going to be a sub-mesh. And so that means I can apply its own material to it, and I can have that material have this hand-drawn element to it. And you all get to see my kitchen now as well. It's very messy. So that's what I want to do. So I'm not going to show you that boilerplate again of, okay, I've been notified that the mesh is updated. I've got the mesh out there, and I'm iterating through the mesh. But this is kind of the main part of what I'm doing here. So for each edge, as I'm going through each edge, I generate a quad. I've just got some maths here to calculate where each of the 4 vertices go. I just add that to the vertices list. So I can add extra vertices as well. Once I've added all the vertices, same thing. I set those vertices back again, so the mesh has its original vertices and also the quad vertices. And I set 2 UVs, one for the mesh itself, and another set of UVs for the edge vertices as well. And that gives me the ability to do that. So there we go. So we're through the code part, an idea about generally we have this way of you can hook events and then add on top or customize point clouds and planes and reference points. So I'm going to go to the completely non-code side here. I've been working in AR for a really long time, and there's just a few common things that I see people do. So I just wanted to point out a few of those. So hopefully it's helpful for you. The first one is expectations. And I've talked about this already a little bit about how when people are working on AR apps, they often sit in an office with the best case scenario, and then they give their AR app to someone to use, and it fails for whatever reason. And they look at their stats, and the stats are way down there. What I find is when people are making an AR app, they expect people to be in the right spot. They don't think about how they're going to get there. They think there's going to be a lot of happy people around who are ready to use my furniture design app. But the reality is, I probably have discovered your AR app when I'm on the train, right? And so I've got this enormous pile of shame of AR apps I've been meaning to try out, but haven't because I'm not in the right situation yet. So what do we do about this? Well, one idea is to have AR as an extension of what you do. I think I remember when the .com happened and everything was some company.com. We're in the AR version of this now. Every company has a big AR in their product name. What we want to think about is AR as part of your product, not to be the product. So this is a good example here of the New York Times app. When I can open the New York Times app on the train and I can read it, and that's fine. But if I'm at home or in a space I can do this, then I can optionally go into an AR extension here and get an enhanced experience. So for people on the web, this is progressive enhancement. It's the same idea. So I think this is something worth thinking about. Always have something your user can do, even if they're not in the right time and place to be doing some AR. The second one is foretelling. This is an example here from an app called Enter the Room, which is made by the Red Cross, and it's meant to give you a sense of what it's like to be a refugee or asylum. And the core thing is I have to place a room down and walk into it. So I need a good 4 or 5 meters of space to be able to do this. So here you can see the visualization of the ghost of what this room's going to look like. So I can, I'm here in my hotel room, I can see, there's not going to be enough space there, I'm going to need to move around and find the right spot, and I can set the right context. So I've had a number of experiences where I spent a long time setting up an AR experience or going through it, and I find, I can't actually do it because people haven't told me what context I need, what space I need. So I think that, this kind of foretelling or giving people a guide to what they're going to need is a really good design principle. This is also something that's very overlooked. I've gone on and on about low light conditions and all this kind of stuff. Errors happen. How do you handle them? Well, one thing I really encourage is to use some sort of analogy. Well, one, to do it first off, because I've got a bunch of AR apps I pull it every now and then and try and use, and I can't, and I don't know why, because there's no feedback. Maybe there's something they require, but they're not telling me. So first of all, have some feedback. Second of all, have some feedback that fits in with your application. The second thing I see is people say not enough feature points, or not enough, using jargon words for what that only I understand, but users don't understand. So this is an app I worked on back in 2012 now. So we had a little monkey here, and first of all, you had to land this kind of cloud-mobile somewhere. This is how you entered the thing. So we had to very carefully started in a 2D world, transitioned people into a 3D world, and then transitioned people into an AR world. So as you start, these clouds are actually attached to the camera. They're not actually in augmented reality. So we use the gyro to tilt them as I do the camera, but as I move around, they're kind of stuck there. So you get like, okay, I'm in 3D now, I've got a character. We get these guides of here, if there's a good landing spot, so we're using an analogy rather than giving people jargon. And if you're not in a good spot, then we also say, hey, I can't see anything to land on, and then give you some clues for what to do. But we can still see the clouds around, and it's kind of fun and work. So even if you're doing a non-game application, there's still analogies you can use and ways you can guide people through that transition, because it's really jarring. I think in AR apps, often people just immediately go into an AR view without transitioning the user through some steps and giving them some context. Next one here is making it real. We've got 2 worlds here. We've got a virtual world and we've got a real world. And often they don't merge together. And sometimes when you're in an AR app, you can really see it looks like something's just floating on my screen. I don't believe it's part of the world. So the core thing I want to emphasize here is anytime you can make these 2 worlds interact with each other, then you're going to increase believability and usability of your app. So this is a very simple example of just putting a shadow underneath a chair. Shadows ground something. So this helps me believe this chair belongs in this room, even though the shadow doesn't fit. There's a strong light off to the right there shining on it. The shadow doesn't make sense, but I do believe this chair's there more than if that shadow wasn't there at all. So leave a mark. This is a tabletop racing game I worked on. You leave skid marks as you drive around the table. So again, this shows the interaction. The car wheels hit the table, and I'm leaving a skid mark, so the virtual and the real are interacting in some way. So we can use physics and occlusion and mark making to say, hey, we belong here. So this is actually a HoloLens example. It's not a handheld one, but I really love this. This is a very strong effect for augmented reality. This is from RoboRaid. So what we've got here is we've got a plane on the wall, and instead of having something just sit on top of it, we've punched something through it. and used a depth mask there, and so we get this really great sense of parallax, and I can feel like I'm looking through my real world into this virtual world. It's a really strong effect, and it really makes me believe that these two things are interacting with each other. So I think anytime you can make something embed or come through or with something real, then that's a huge win. So this is just a lighting experiment I did. Again, it's showing the interaction of lighting. Lighting's a very strong thing. So what I'm doing here is I'm getting the camera background, and I'm using that camera background as a skybox effectively. So we get these nice reflections on this character. So you can see as the robot walks through this room, you can really see the red jacket shining off. It's not at all accurate. It's not at all. If you look closely, this is not accurate, but everything's moving quickly enough and fast enough. So light levels, anytime you can get some color in, anytime you can make something where something changes in the environment, something changes with my character, then again, you've got a huge win. I haven't ported this example to ARFoundation yet. I will. This is for ARKit and ARCore. It's on my GitHub if you wanted to see how it was done. If you're going to do this in ARFoundation, you'd use the camera API that I showed you earlier to grab this texture, put it into a skybox, and use that for lighting. So the last thing I want to talk about is Mars. Has anyone heard of Mars? Okay, great. So what we're thinking about here in augmented reality is a fundamentally different way to create something, because when we're making a game, we make the environment. It's the same every time. When you're working in augmented reality, it might be in a dark bedroom, you might be in an office, you might be on the train. You have all these different sorts of environments you're working with. So what Mars is, it's come out of our labs group, and it's not quite available yet, but it'll be available soon. But it's got two things. It's got simulated environments, so you can test out things in different situations. And it's also got rules-based authoring. So rather than using code, what we can do is, I want to look for something above a certain height that is a certain distance away from me, and I'm going to place something there. I want to look for something that's on the ground and place something different there. I want to look for something on a wall. So you can do this spatial reasoning, and it's all rules-based, it's all visual way of hooking up how I want things to behave in my world. So I'll show you what that looks like. So first of all, here's the simulation part of it. I've actually got a video of this. So on the right-hand side, this is the traditional scene view. I've just got my objects here I'm authoring and playing around with. And on this side here, I've got my different simulation spaces. So I've made my rules, and I can see how they behave in different situations. So here I've got this rock thing on a coffee table, and if I've got something at a different height, then I've got my grass. So I can start to test and see how these rules play out. So you can imagine there's a huge thing for content authoring, they have to do things by hand. And let's have a look at, this is it for real. This is in our San Francisco office. So as I move, I find a table at a certain height, I put some grass down, another table at a certain height, and I put a grass down. My character pops out, but my character's aware of all these different spaces now. They're connected. So the character can jump down, or you can use a nav mesh to make it move around the world, because the floor has a different sort of environment on it. Come up here and go to the other side. So it gives you a great starting point for this sort of real-world reasoning. So it's a really powerful way of authoring. Here's an example for faces. So I've got the real world and simulation space, and I can start to do some face authoring and see what it's going to look like in reality or in simulation view. So that's how we're thinking about the future of this authoring. I've showed you lots of code here, but I think the future is much more about rules and simulation. So that's it. All the best for making your ARFoundation examples. I'm happy to take questions. Does anyone have any questions about what we've talked about so far? Okay, thanks very much.